Although combining data from different data sources is very powerful, as an analyst you need to take care if you make any changes to your data in this process. As data is aggregated or disaggregated, some changes will occur. When you transform your data from a different data type, remember we talked about choosing the data type based on the questions you're going to ask of your analysis and the scale of your analysis. But all of these changes can impact upon your results. The results you get from the same data set over the same study area can vary enormously simply by aggregating them in different ways. This is termed the modifiable area unit problem and was a phrase first coined by the British academic Stan Openshaw in 1984. It's a problem, and it's not one that can be solved, but knowing about it means you can be more careful in what you do with your data and how you interpret the results of your analysis. Information known for an area is often a summary of measures found within that area, such as the number of schools within a county, the people per square mile, your population density, and that information represents the whole area as if it were uniform. The location of the boundaries of any area unit affects the values within that area. That's pretty obvious. So imagine if the boundaries were drawn in a different configuration. Imagine if they're changed. Then any incident data, locations and their attributes are going to be aggregated in a different way. So your data is going to change slightly. Your analysis of your area and the results that you get are therefore going to be different. What's inside is different, and therefore you have different values. Many of the area units are arbitrary. There aren't visible lines that you can cross, or there may be blurred lines. Often they're administrative areas, such as the census regions, health regions, school zones, even postal delivery zones. Take, for example, data on social characteristics such as race or income. These are often only available for census areas, rather than from the individuals within the area. And over time, these census areas may change as the administrative boundaries are moved. They may be modified. Or you may find that you need to make changes of your data. If you need to do your analysis within health regions and you're using census data, you need to change your census data into the new boundaries. You're making change to that data set. The boundaries that you're working with have now been modified. So in either of these cases, the data has been modified. The placement of the boundaries of original data is a convenience of what that data was collected for. The decisions made when using census areas are very different to the criteria that would be based for placing boundaries if you're delivering mail. So as you represent the real world using spatial data, or even when you're consuming other people's data, consider the scale of your analysis. Consider how it's being represented within the area and the effect that that has upon your results. Use the appropriate boundaries for your analysis. The same issues apply to scale of analysis that we talked about last week. So that in some way is going to modify the boundaries that you're using within your data. If you're looking at a more local scale, so smaller boundaries, than if you're looking over much larger regions such as counties. So the results of your analysis will be affected by these decisions and are therefore related to the scale of the analysis. What it means is you can't assume any observations you make using data with one set of boundaries would be observed with any other subdivision of that data. That doesn't mean that what you see within your data, your observations are wrong. It's simply that your results are partly a function of the area units that you've used for your analysis. But as long as you chose them appropriately, then that's the results you're looking for. You also want to take care when you visualize and map area data. If you have a total value for an area, you need to take account that area. The area is part of the calculation. So if you have the number of crimes by police area, then you need to normalize those counts as you're displaying it by area. So you take the count of crimes and divide it by the area. You're transforming your magnitude, your count, into a measure of intensity. Thereby you're including area when you're mapping your results. That way across your map there's a consistent basis for comparing the values relatively. Using normalization, you can then compare differences between areas. You can make the comparison using area, or you could use something like population size. Ratios such as means, medians, percentages, or rates are already measures of intensity, so they don't need to be normalized. You're often going to see maps that display a value using a single color across an area, shaded light to dark. These are called choropleth maps. Choropleth maps should always show normalized values and not counts if they're being mapped over unequal areas or populations. Otherwise, you're not presenting that data correctly. Unfortunately, this is a really common error, but it's a really good map type, a common type, and useful. So it's worthwhile understanding this common pitfall and getting it right. The ability to combine data from many different data sets using spatial data makes GIS so valuable for evaluating and analysing data. You can derive new information that hasn't previously been explored. You can explore interrelationships between data sets. But understanding where your data is from, the effect that it has on your results, is crucial to understanding how you should use it properly. Better understanding your world comes through the ability to break down your problem, focus on the specific issues, and that includes understanding the way the spatial data is structured and the impact that that's going to have on your analysis.